Okay, continuing along with our last three questions of our 8 for related to surface area and volume and area and perimeter of two-dimensional and three-dimensional shapes. For continuing along with the surface area and volume of prisms, we have a triangular prism. And before I go on with this, I want to make sure you all understand that if I was to break down a triangular prism into what's called a net, the net would look something like this. A triangular prism has 5 faces, 2 of which are triangles, and 3 of which are rectangles. And when you know that that's the net, then the formula is not complicated because it's simply 2 triangles and 3 rectangles, right? The formula makes sense when you understand what the net looks like. And once you have that, all you have to do is substitute the information into your appropriate formula. I'm going to grab a highlighter here and just show you that. This 10 right here, uh, does that have any bearing on the surface area of this particular one? Yes, it does. It's the height of the um, prism if we're looking for volume, but it's also going to be, if I look here, one of these measurements here. So it's actually going to be a part of the rectangles. When I look at this part here, the triangle, I should go back and, when I look at the triangle, the base and height are going to be right here because the perpendicular distance between the base and the apex of the triangle is known as the height. So therefore, it doesn't matter if you go 3 and 4. We're just going to go 3 times 4 divided by 2. That's the area of one triangle. And if I double it, that's what it looks like. Plus, if I think of this first rectangle in the front, it's a 10 by 5. If I think of this rectangle over here that I can't see, it's going to be a 10 by 4. And if I think about this rectangle on that side that I can't see, it's going to be a 10 by 3. So the abstract thinking required to kind of visualize that two-dimensional rendering of a three-dimensional object is kind of tricky for some, but that's what it looks like. If I was thinking about multiplication of that by 2, some of you understand that that's an opposite operation, and you can get the answer 12 right away. If you didn't do that whole cross reduction, you did 3 times 2 is 12, and 12 divided by 2 is 6, and then you multiplied it by 2, but you still got 12. Either way, the two triangles' areas are going to be 12 when added together, plus 50, plus 40, plus 30. Now that we have addition, that's 90, that's 100, that's 130, that's 132. Since I didn't actually give units for this one, the surface area for that triangular prism will be 132 square units of space. When we look at the volume, again, because it's a right prism, the formula is always the same, area of the base times the height. What kind of base does this have? Well, if I think about it here, the base, or the side that is on the ground where the others go perpendicular to it, is actually a triangle. So the area of that base will be expressed by base times height divided by 2, multiplied by the height. And as we said in the first, this h is actually this 10, the height of the prism. So our base is going to be 3 times 4 divided by 2, multiplied by the height, which is 10. 12 divided by 2 times 10, 6 times 10. The volume is 60 cubic units. That's how much space fills that particular vessel. 60 cubic units of space. Our next question is an actual cylinder. Oh, I better keep that there. That's important. Surface area. There are 3 faces. If I drew the net, it would look like this. 3 faces. The formula for surface area is 2 circles, which is represented by 2 pi r squared, plus this rectangle here. This circumference and this length are the exact same measure. And this measure and this measure here are the exact same. So instead of saying length times width, we're going to say circumference times height. Circumference times height is the formula. But since there is an already formula for circumference, what is the formula for the circumference of a circle? It is pi times diameter. So from a standpoint of what is the formula for the surface area of a cylinder, it's two circles and a square, or a rectangle, excuse me. So when I write that down, you understand why it is what it is. And then you substitute your information, 2 times 3.14. The radius, since the diameter is 10, the radius would be half of that, or 5. The height is 12. So when I substitute my information in, the diameter is 10, so D is 10. The height is 12, so that becomes 12. Substitute it using bed mass. I'm just going to expedite this a little bit. And then that. So once I do that, 6.28 times 25. 6.28 times 25 equals 157. And 3.14 times 120. 3.14 times 120. It's 376.8. Should have wrote it there. And when you add those two together, the total plus 157. Your total surface area. Can I put units for this one again? Nope. Is 533.8 square units of space fits on the outside of that cylinder. And the second part to this is the volume. Again, the area of the base times the height of the prism is the formula. Since the base of a cylinder is a circle, it's pi r squared multiplied by the height of the prism. 3.14 times 5 squared multiplied by 12. 3.14 times 25 is 78.5 times 12. I have no idea. 78.5 times 12 equals 942 cubic units. Or if you want to put units cubed, you can. Either one's fair. And that's the volume or the capacity that vessel or that container can hold. Our last question is a composite two-dimensional figure. It gives us a square with an inscribed circle with a triangle in the middle. And it says devise a formula for two things. It says what's the formula for the white and what's the formula for the red. So we'll start with the white. If we think about the white, the actual square that's here is unnecessary, right? If I remove that square, it does not have an impact of how much white there is in terms of space. So really, the formula for the white, how much white there is, would be the circle, take away the triangle, right? The circle, take away the triangle is how much white is actually there. So therefore, your formula would be pi r squared, take away, base times height divided by 2. That would be your formula. For your red, now we do have it. It's a square. Take away the circle of white plus a triangle. That's how much red is there. It's a square, but it's not all of the square's area because the circle has been taken away from it, but the triangle has been added. So therefore, our formula will be side squared minus pi r squared plus base times height divided by 2. Those are our formulas. And if you solve it to figure out how much area there actually is, then you'd have 3.14 multiplied by, here's the tricky part. What's the diameter of the circle? Do you see it there? The diameter would be the distance from here to here, wouldn't it, of that circle? Would you agree with that? If I remove this red triangle, do you see it? What's the length of that black line? 7. So what's the length of the radius? It's 3.14, isn't it? Right? Or 3.5, sorry. 3.5, thank you, squared. If we think about our triangle, we have enough information that's already been written there. Bring this down. Take away 6 times 4 divided by 2. So when we substitute our information, that's what we get. So when we work it out, that's what we get for an answer. So therefore, the area of the white is 26.465 square units of space. When we do the same thing over here, the area of the red would be 7 squared. Take away 3.14 times 3.5 squared plus 6 times 4 divided by 2, which when you work that out would be 49 take away 38.465 plus 12. And when you work that out, 49 take away 38.465 plus 12 equals 22.535 units squared of red. That can't be right, is it? Oh, yes, it is. That can't be right. That can't be right. Okay. Any questions?